Good morning. I'm Jeff Hammond, Executive Director at IGSHPA. Welcome to our February Town Hall. We're excited to have Tony Amis of Endurant Energy join us this morning. Before we get started with Tony, I have just a few announcements to bring everybody up to date on what's happening with IGSHPA, and then we'll turn it over to Tony. Thank you for joining us this morning. So we'll talk about just some of the latest IGSHPA news. If you are interested in presenting one of these town halls or a Dig Deeper webinar, check out our events and training menu on the IGSHPA website, IGSHPA.org, and you'll find a form that you can submit an abstract for either a town hall or a Dig Deeper. We still have some slots open for 2023. So if you're interested, you might want to do that just as soon as possible. They're filling up quickly. And along those lines, as you noticed on our title slide, GeoExchange is our sponsor for this town hall. If your company would like to sponsor one of the town halls or Dig Deepers, go to that same location and click on the sponsor link. That'll give you a flyer for the various costs and opportunities there. And again, we have some openings available. Our annual conference, you want to save this date. We're partnering again with National Groundwater Association, and this year it is back in Vegas again, December 5th through the 7th. We'll be sending out a lot of details here soon. We met with NGWA already and have a pretty good plan of action. So watch for your email and newsletter traffic in your inbox, and you'll find out more information about the conference. We hope to see you in December in Vegas. If you haven't noticed, there's a new interactive directory on the IGSHPA website for business and corporate members. You just click on the state or province, and it'll bring up a list of various sectors. If you're looking for a contractor, an engineer, a driller, what have you, you'll be able to search by the areas that those companies serve. And once you do get to that point, you can search by a lot of different filters and find that company, and then all the details accordingly. So check that out. If you're a member, you're already on the directory. If you're not a business or corporate member, you can go to the website or contact us, and we'd be happy to talk about that. If you'd like CEUs for this town hall, please send a chat message with your name and your email, and Sally will record that, and then have a certificate sent at each half CEU interval. So just send that in the chat, and then she'll keep track of it. Just a little bit of housekeeping. As Tony's speaking, please submit any questions in the chat feature. At the end of his presentation, then I'll read those questions and give Tony a chance to answer. If we don't get to all the questions, then we'll reach out afterwards. If you would, please put your microphone on mute to make sure that everyone can hear this presentation. We will be recording it. It usually takes a day or two to get that online, but check back at IGSHPA.org. There's a YouTube icon at the very top. Once you click on that, then you'll find the February Town Hall, and you can watch that YouTube video with Tony's presentation. Just a quick disclaimer and conflict of interest message. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA Town Halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of this webinar. All right, with that, we will introduce Tony Amis. And let me stop screen sharing here and let Tony switch over. Tony is, over the past 35 years, has been working in the construction industry and has been managing large foundation civil engineering projects in the UK, Hong Kong, and Singapore, and more recently in renewable energy solutions in the USA. At the same time, and over the last 20 years, he's been raising the profile and opportunities associated with renewable energy solutions due to ever-increasing concerns around the world related to global warming and the harmful effects we place on our planet. With his background in building foundations, he has especially drawn to the simplicity offered by ground-sourced heat pump solutions and became specifically associated with raising the profile of geothermal opportunities, largely through the use of energy piles which are geothermal loops installed within the building foundations. A key player within the GI Energy UK operation between 2008 and 2017, and now Endurant Energy, formerly GI Energy US. Tony's involved with raising the profile of all ground-sourced heating and cooling systems, both in the UK and internationally, and at the same time continuing research into the effects on foundations with multiple universities in the US, UK, and Europe. Tony's presentation today is the one that he did at the annual conference in December. And so if you weren't able to go to our conference, you'll have the pleasure of seeing it today. With that, I turn it over to Tony. Thank you so much, Tony.
Thank you. Thank you, Jeff. And massive thanks to both you and Sally for what you do for IGSHPA. It's a very important organization for sure. Organization, association, I don't know if there's any difference. I'm sure there's some legal difference, but yeah, thank you very much. And the only other thing I'd add to that sort of resume would be that I am sort of chairman of the CSA Energy Foundation Committee for Energy Foundation Standard, in conjunction with IGSHPA. Forget all the affiliations associated with it, Jeff. What's the true terminology? CSA?
It's the ANSI CSA IGSHPA C448 standard for design and installation of ground source systems.
Don't you just love acronyms, eh?
Yeah, right.
Cool. All right. Yep. So thanks for that. So yeah, so I'm Tony Amis. I'm just trying to go to the next slide. Here we go. I've been part of the geothermal world for I kind of feels like 15-20 years now. I came into it by accident because my speciality was drilling project managing foundation projects for Skanska in the UK. And one day I came across a team of guys that seemed to be trying to shove a hose pipe in the ground. And so what you guys are up to? And the guy said, well, this is a geothermal loop. And that was my first introduction to ground source heating and cooling back in probably 2004. And it turned out to be a company called Geothermal International that I ended up working for 5 or 6 years later. And it's been quite an incredible journey. But that journey has learned me, my organization, a lot of lessons. And one of the most important lessons is, you know, it's all well and good to design a system, but what you need to be doing is being involved with the construction aspect of it, and then being involved with the long-term management of the system. You know, and that's exactly what we do as a business. So it's all about early engagement with a developer, demonstrating the benefits of a geothermal solution, exploring what the financial options are. You know, energy as a service is a key goal of ours. But then once we've done that, we want to potentially take the developer on this journey and de-risk it for him, and be involved with the engineering and design right the way through to construction and installation. The energy model that gets developed during the engineering and design phase is the crown jewels of everything that we do associated with the geothermal. The heat pumps connected to the ground loop are an instrumental part of this solution. So we've got a geotechnical group of people, which is kind of where I originated from, now moving into a mechanical engineering world. So you know, we get this geomechanics integration, which is kind of like a new subject almost. But it's very, very important that that energy model, once the system's operating, we get clarity as to, well, how is the building performing in reality? Is it performing as we expected it during the design? And some of the solutions that we've installed, you know, the energy model, when other parties have given it to us, you know, it's been designed as if it's a conventional gas and gas-fired boiler solution and traditional cooling. You know, so the quick solution there is designing peak heating and cooling. With geothermal solutions, it's more seeing what's happening on an hourly basis. But importantly, once the building goes live, it's then is our design assumption, are our design assumptions correct? Can we manage the system better? Can we optimize the geothermal system? Can we deliver more heating? Can we deliver more cooling without affecting the long-term performance of the ground loop? You know, it is a holistic project. And we've learned many lessons where somebody's come along to us and say, "Oh, just design the ground loop for us." You know, that's not enough for us. We need to be responsible for what gets attached to it ultimately. So walking through, I've just walked back from a meeting in the city of New York, and you've got all these tall buildings around. How on earth would you do a ground source heat pump system in a heavily built urban area? There are some great solutions that are available. So, you know, again, going back to the first stage of a project, we'd be talking to a developer, looking at and exploring options for him. Is there a sewer pipe nearby? Are there other water sources available? And I'll come on to that in a little while. And hybrid ground source heat pump solutions deliver base heating and cooling loads combined with an air source heat pump, provide a better resilient system if you design the air source heat pumps to perhaps support the ground source heat pumps in a greater way. If there is some sort of failure. You know, in terms of the Inflation Reduction Act, we would be designing a ground source heat pump to try and deliver 75% of the building's heating and cooling loads. If below that, the IRA is not eligible. So on a city centre building like this, first thing that we look at is, well, how deep are the foundations going to be for this building? They're being constructed anyway. So why not put a geothermal loop in it? It may be that we've got to have supplementary boreholes. It may be the foundations are too short. So what about drilling boreholes underneath the building? And it could be a combination of all of those. So over the last 2 or 3 years that I've been here in New York, we've done some great studies with the thanks to NYSERDA PON 4614. You know, we've looked at a multitude of projects, affordable housing, schools, commercial buildings, and one of the things that we've looked at on probably a couple of the projects is in connecting into existing sewer runs. And what we're seeing here on one particular project, that the adjacent sewer flow rate of between 19,000 and 51,000 gallons per minute was able to deliver all the peak heating and to deliver the entire heating and cooling load for that particular building. The beauty of this type of solution, it's obviously not particularly invasive as far as a geothermal solution goes, when you consider that you know, what a borehole solution might have. It may require sewer upgrades. You know, so it ultimately avoids the necessity for drilling potential boreholes for a geothermal solution. Here in New York City, you know, there are issues with permitting, and you know, we just need to make sure that you've got the time on a construction schedule to deal with all the kind of permitting. Another opportunity that we are heavily engaged with on one of our projects, where we've got 46 towers, they are located next to a water pipe that is literally is kind of connected to multiple stations across New York City. Underground railway stations, and they're pumping water out, 13 to 20 million gallons of water every single day, straight into the Hudson River, the East River. So we're looking at an opportunity where we can intercept that water and deliver all the heating and cooling to 46 towers using this water. Ironically, this is one of those systems where the water is being, if the pumps are switched off, then the stations themselves flood. So it's important for the railway authorities here to maintain those pumps at all times. So it's very unlikely that those pumps will get switched off. So it presents another great opportunity, and the diagram on the right there shows that it's a very simple connection to that plate frame heat exchanger, and put the water back in. The plate frame heat exchanger there enables us to exchange a pretty low grade amount of heating and cooling and transfer it into the heat pumps to then deliver the heating and cooling that's necessary to each of the towers. And there's absolutely no reason why, you know, 300 or 400 feet down the road, we can do the same to additional properties. So it makes for a perfect solution in a city centre environment where it's all about looking outside the box rather than just saying, okay, where can I put some boreholes? We've drilled boreholes under the basements of projects, certainly in the UK, not so much in the US. I know there are projects underway in New York City here where there are boreholes going underneath. Again, it's all about mitigating the construction sequence here. That's an additional operation that needs to be taken into account in those early days. But one of the things that we've come up with here is rather than drilling from ground level in this deep basement case, we said to the contractor, will you excavate the basement, put us a nice hard surface down, and we'll drill those boreholes. In this was a university project in Oxford, and we'll drill the boreholes from that hard surface. Firstly, the guys doing the drilling here were able to work in a really nice, tidy, clean environment and not trudging through mud and clay, which increases obviously the health and safety aspects, but it also increases productivity. And then probably, I was going to say use the words more important, but nothing's more important than health and safety. But here, in this particular case, we were able to, once those boreholes were complete, you've got the tails coming straight out in, and we were able to, the next stage here was for the contractor to lay the foundation mat. And we were simply running through that mat. So in this particular case, if we'd have drilled those boreholes from the surface, when they were excavating, that particular basement, there's the potential for a lot of damage to geothermal loops during that phase. The way we did this particular project mitigated that extra risk. It mitigated construction schedule time. So it's all about looking at other opportunities and thinking outside the box. And in terms of thinking outside the box, my geotechnical background working with Skanska many years ago, why on earth can't we put geothermal loops into the very building foundations that are being installed to support buildings? Here in New York, JFK Airport, 120 to 200 feet driven steel tubes. There's an absolutely, every time I go past a site where there's a piling rig on it, my heart sinks because it's an opportunity missed for an energy foundation solution. So what is an energy pile? The picture here describes what you see. The important thing here is to engage with the geotechnical consultant as early as possible, and then the piling contractor, the foundation contractor, because ultimately all we're wanting to do is attach a geothermal loop to the reinforcement that he will be installing as part of the foundations that will be supporting the building. So straight away you can see minimal costs associated with this. And importantly, one of the projects that I worked on, highly contaminated grounds, they were able to use a piling technique that mitigated the amount of material that was brought out of the ground. And drilling boreholes in that particular case would have produced an enormous amount of contaminated material, which adds significant cost to a project. So again, coming back to energy foundations, this really is a low solution cost. One of the largest projects we did in the UK was this one you change. This is a photograph from St Paul's Cathedral. We delivered a pretty big chunk of heating and cooling capability on this project. And this has been operational since 2010. Now, going back to monitoring and managing systems, one of the things here, these guys had gas-fired boilers installed as part of their heating requirement. And I understand from talking to some of my old colleagues that they're currently working out that they've monitored and understand the true energy requirements for this building, and they're in the process of removing all the gas-fired boilers from this solution because they've identified that they can deliver all the heating from the energy foundation solution that was put in here. On this particular project, the piles here were 10 foot in diameter. We had about 6 loops in each of the piles. So I was working for Skanska at this time. So I was on the other side of the fence, working with Geothermal International, now GI Energy, now Endurant Energy. And again, there was no construction schedule impact for this type of solution. These guys were only ever going to do 1 pile a day. And the addition of these loops, there was a bit of preparation work, but it didn't affect the construction schedule one bit. No additional materials, excavation material was needed. So again, it kind of plays into the benefits of this type of solution. There's no additional area required outside of a construction project potentially that could freeze up the ground for future construction. You put a borehole in the car park area, you can't build out in that area in the future. If you use the foundations or drill into the building, you've got that geothermal system protected by the building itself. We've done many projects with boreholes in car parks, and we've ended up having to go back to do repairs because a utility company comes along with the latest technology to install to the building and cut straight through our geothermal loops. Energy foundations, boreholes under the building has not generally required the same kind of return to site for any repair at all. So it's all about getting it right first time in that kind of situation. And the way you operate an energy foundation solution, very dependent on ground conditions, but it's all about sort of creating a thermal battery under the building. So by providing cooling in the summertime, we can warm up the foundations in readiness for a winter situation. And then in the wintertime, we can deliver more heating, cooling down the ground in readiness for a summer situation. On the One You Change project, we were downloading weather data so that we could prepare the ground loop in readiness for a weather event. So when you get into the drilling foundations for building, you'll realize there are multiple solutions. And I have personally, I don't think there's one piling solution that I haven't attached a geothermal loop within that type of foundation. It all depends on ground conditions. Here in New York, I use JFK Airport, they're driving steel tubes. So very much like the situation you see here on the right, steel tube, drop a reinforcement cage in. It's very, very straightforward. It's all about coordination as early as possible in the process, initially with a geotechnical consultant and then the foundation contractor. And these loops can be installed without any impact on a construction schedule at all. So this is the project over in California that I was involved with in 2017. This is the Google Bayshore project. 3,500 energy foundations went in here. Now, interestingly, the piling contractor here said, "Oh, we're going to get probably 10 piles a day." No, that's our construction schedule. What they ended up doing was 30 piles a day per rig. And I think the problem they had was that concrete was the grout became the key issue there. We just had to man up to be able to maintain their sort of schedule. But you can see on the left there was a lot of pretty straightforward preparation. We had spacers that had a little clip in it, so it's pretty straightforward. We were able to keep well ahead of their construction schedule, and had no impact. Now, this is the site that had high contamination. So as they were drilling and forming the foundations with what they call a displacement pile, the material being forced into itself. And obviously with 3,500 of these piles, you get this ground heave effect potentially. So every single pile needs a full length piece of reinforcement. So all we're doing here is attaching a geothermal loop to that single piece of reinforcement. And in this case, those piles were going down 120 feet. So the picture on the right there shows 4 piles completed in series, which is almost the equivalent of 1 borehole. These guys were drilling 30 of those piles a day. And traditionally, from in the past, all I've seen is a borehole, 1 or 2 boreholes being drilled per day down to 500 feet. So again, you can see there's a schedule improvement by going down this route too. So yeah, which brings me on to dense urban areas. This is a project that I was involved with since 2020. Actually, I had to come back from the UK in the middle of COVID to help manage this. So we had 250,000 feet of commercial space, 300 tons of peak cooling, 70 tons of peak heating. Now they wanted an all-electric building, so they were designing this with radiant slab heating and cooling, which, for those who know geothermal, radiant slab heating and cooling is a great combination. So this was what the basement looked like after we'd completed the energy foundations. 62 foundation piles, with 3 loops in each. So the first important thing is to understand the geology of this project, and then obviously work out and make sure we've got the right energy model. As I said, very important. Various iterations as the mechanical engineer, the architect are working, discussing sort of the facade. Changes to the glazing of the building can have a significant effect on the heating and cooling loads. So as they were changing things, that we were there in the background, demonstrating what the impact of that would have on the energy model, which is a very important sort of relationship with the buildings that you're working on. So we came up with a solution where we put just 3 geothermal loops in each of the 24-inch and 36-inch piles. So we had 192 geothermal loops in 120-foot deep piles. We had a couple of small piles in the corners. They were 13-inch. We didn't put any loops in those. And then each individual pile was then run back to a sub-manifold. So this was the detail in each of the foundation piles. They were installed independently, the three loops, and then obviously once the pile was trimmed down, we then formed the circuit, which was then run back to a sub-manifold. So what you see here is the kind of, I think, there you go. So what you can see is each pile with 3 loops in it is then run back to its own manifold. The beauty of this is it then enables us, if there does become an issue with this one particular pile, we are able to then isolate at this sub-manifold location before it runs into the whole system. So during the design process, the resilience aspect of a geothermal system under a building is an important consideration for sure. And so these are what the typical sub-manifolds would look like. So each of those loops is a single pile with 3 loops in. And on the this 561 Greenwich project, the foundations themselves, we calculated that we could deliver 31% of the cooling and 38% of the heating load. And there's a great solution with multi-stack where the heat pumps they can operate as ground source mode or air source heat pump mode. But what they need to know is, well, what is the most energy efficient way? So there's a control strategy that needs to be bolted onto this system that then enables the heat pumps on the roof of this building to then operate in either ground source or air source heat pump mode. So let's dive in the construction of this. So again, you can see this was a typical reinforcement details for this building: single bar, full length, single piece of reinforcement. The big black pipe there was for grouting. That was left in place. The only additional cost to the piling contractor in this particular case was on the plates. Yeah, I don't know if you can see my mouse here. There's a little sort of cut that was cut out that we then fed the geothermal loop into as this piece of reinforcement was being loaded into position. So again, it's preparation, getting the loop reelers in position ahead of the piling contractors. Piling contractor had to lift the loops in place for us anyway, so we were always at the mercy of the foundation contractor, and we were always ready. So you can see some close-up shots of how the geothermal loops are placed around the perimeter of each of the piles, and installed. I think, if I'm right, this might be a little video clip sped up of the geothermal loop being installed. The reinforcement cage was added in 3 sections, and we spent more time waiting for the piling contractor to weld his and extend the reinforcement and the grout pipe than he did waiting for us. So you can see that's pretty straightforward operation. And then one of the key things for this kind of solution under the buildings, it's about getting it right first time. There's trimming that's going to happen to the pile, so that final trim level needs to be carefully protected, because you don't want these loops being damaged. And then in making the piling contractor trim deeper, it is always going to become a problem. So yeah, making sure those end up at the right position in the pile, and very importantly, flow test, pressure test every single pile. You can never do enough flow test and pressure test. Each key stage then gets signed off. Now, interestingly, the next phase of work is obviously the excavation to form the basement. And this is the bit where it concerns me most of all. But what I was very surprised at here was how bomb-proof the HDPE loop was in each of these cases. There was quite a lot of cuts and abrasions, and in quite a few occasions the light loops have been stretched. But what you can see here is when they get down to the trim level of the pile, the protection over this particular section is important. We don't want that being damaged. Because this is where we're going to cut the loops. We're going to do another flow test and a pressure test, and then we're going to make our runs back to the sub-manifold. So you can kind of see the process here: pile trimming, preparation work, and then the pile cap being prepared. Now this would be a significant hold point. So before the piling contractor is allowed to form a pour concrete in this particular case, we would say we need to do a flow test and a pressure test. And you can see that the pressure gauge on at each of the key stages. So we're monitoring loops. They're filled with water at this stage, and there's a regular check to make sure that there's no drop in pressure as work proceeds. So yeah, this was probably June 2021. So what you can see here is each of the sub-manifold locations. So we've got groups of piles run back to each of those locations that are circled there. So on the drawing on the right, you can actually see the location of that. And then the sub-manifolds are there on the right-hand side. And again, what's important once you get back to this phase is to lock in the water and keep it under pressure. So you've got a record that the system's operational and not been damaged at any stage during the works. We did have one situation in this bottom right-hand corner where they were drilling in for some scaffold support, and they did puncture one of the loops. But we noticed because the pressure dropped off, and there was a simple repair that had to be undertaken. So you can see here how we've kind of started. We've got 2 circuits effectively here. We've got the left-hand side, let's call it the west side, east side, and the west side. So the two sides of the site are separated with a reverse return system. So each of the sub-manifolds will then run back to the main manifold. And what you see here is the kind of I mean, this was the architect's detail anyway. So we're just running the reverse return loops from the sub-manifolds back to the main manifold under these panels, which are removable. So again, if we needed to access these sub-manifolds at a later date, which I hope we never do, then it can be done. And then, like I said, so heat pumps are now on the roof of this particular building. What I like about the multi-stack units here are they will operate in ground source heat pump mode or air source heat pump mode. So it makes for a great hybrid solution, especially when you're looking at long-term management and resilience of a solution. So I mentioned earlier how important it is to monitor systems. So on this particular case, we installed some temperature sensors and vibrating wire strain gauges in 2 piles with geothermal loops in, and we installed it in one of the 13-inch piles that doesn't have any geothermal loops in it. That information is going to then, well, it's already generating a lot of interesting data. What you see here is results. So we've got temperature sensors throughout the depth of the pile. And interestingly, what you see here is the temperature of the ground at the basement level was 70 degrees, rising up to about 73, and then dropping off down to about 62 degrees. So interestingly, far warmer than we expected during our design. So there's a big opportunity. This system should go live just as we're running into a winter situation. So we're thinking we're going to be able to deliver a whole lot more heating than we can. But this data then enables us to then provide the sort of optimization and fine-tuning of the type of solutions that we are designing here, and making sure that the energy model that we were given at the beginning to design the system to is a true picture of what's actually happening. The idea would be is that we review that and then modify the system accordingly. And then through the control strategy, we're sending signals to the heat pumps on the roof saying, yes, we've got availability to deliver heating or cooling today. The heat pump themselves will be measuring air temperature. We'll be sending ground loop temperatures, and by a quick calculation, we can work out what the best COP is for operating either the ground source heat pump mode or air source heat pump mode, and then ultimately delivering low cost energy heating and cooling solution to the building owner. Ultimately is the intent, and also low CO2 emissions. So very important to manage and maintain through the life of the building. And yeah, last slide. I'm keen that there should be some building code legislation that says if you dig in a foundation deeper than 60 foot, you know, we should be putting a geothermal loop in it. Like I said, every time I see a project where piling rig is on site, there's an opportunity going missing. And I know the foundations at JFK Airport, a lot of the airports that side of New York City, there's some very deep foundations being installed. So we should be putting geothermal loops in every foundation pile that's being installed to build to support structures, basically. And that's it. Any questions?
We have a lot of questions, Tony. Thank you for a great presentation. I'll just start reading through the chat questions. There was quite a lot that piled up here while you were speaking, so that's the sign of a lot of interest here. Victor comments here and asks a question. Assuming piles are already part of structural design, under which conditions would you recommend piles over traditional vertical bore under the building? For example, is there a target pile depth you have in mind for feasibility?
So as a rule of thumb, I've always felt that 60 foot, 20 meters pile depth is a good solution, for sure. But it's the hybrid approach. Can we make it, 60% ground source, 40% hybrid solution? For me, is always seems to have worked out to be the sweet spot for this type of solution. So can we get enough heating and cooling out of the ground loop to really make it worth it? The One You Change project, we added in an open loop well as well to that solution. So I think hopefully that's answered the question. 60 foot, 20 meters would be a project that I would certainly immediately say there's got to be an opportunity here. But the height of the building as well. And the 561 Greenwich project was 14 floors high. And my view is that when we get to see the true energy model for that building, I think we're going to find that we're delivering a whole lot more heating and cooling capability. I think the energy model will be probably extremely conservative. And what we're actually doing is we've got the capability to deliver a whole lot more. But what we've got some great instrumentation going into that project that's going to enable us to confirm that.
Okay, exciting stuff. Thank you for that answer. Bill asked the question, if the piles with geopiping are surrounded by concrete and concrete is known to shrink upon curing, how can direct contact for optimum conductivity between the piping wall and the ground heat exchanger be maintained in the same spirit as grouted boreholes?
So concrete shrinks. Yeah, so concrete shrinks. So when you put the loops in the foundations, we generally fill them with water anyway. And then systems pressurized. So I'm imagining that, I mean, at depth, I don't think there'll be a great amount of shrinkage. The actual design of the concrete mix for foundations is pretty strict, because obviously the concrete serves two purposes. It's to obviously support the structural elements of the still within the pile, but also to protect it from corrosion long term. So concrete mixes are generally very carefully designed, and during the construction process, there's a lot of testing goes on to verify cement contents, strength, things like that. So I don't imagine there to be a great deal of shrinkage on the foundations that are being used to support large tower, large structures.
Okay, excellent. Good to know. Terry asks, is it proven by trend data that piles that are heated up in summer can provide any significant heating in winter and vice versa? I.e., is that claim defensible?
So in London, you've got a really down to probably, I think it's about 60, 70 meters. On the One You Change project, you've got London clay, which is a lovely material to dig through. You can actually dig, I mean, those 10-foot, I think they were 12-foot diameter piles were dug, short casing, down to, I'm just trying to do a quick, about 60 meters, 180 feet. And so they were dug without any sort of support fluid. But the conductivity of London clay is identical to that of concrete. So we kind of just refer back to, in the UK, there was a lot of night storage heaters, where, because electricity was cheap over the night time, people would run their night storage heater using cheap electricity. Then it would switch off when the sort of the tariff jumped, but you then have that nice radiant heat coming out from it during the morning time, and then it would come on again when the tariff was low. So I mean, that would be how we would design a system that would enable us to treat the ground as a thermal battery. If you've got a gravelly material underneath the building, and indeed the Greenwich project, because of our proximity to the Hudson River, we kind of felt that there would be a lot of, as the tide came in, we would see sort of a constant recharging of the ground temperature there. I think what we saw was, we didn't see that. What we saw was, the effects of the heat island thermal effect. So yeah, I think it can be, it is defensible.
Okay, thank you, Tony. Next question we have from Tom. What protection is used in energy piles if geoloop approaches freezing conditions? So
one of the, I mean, most buildings are cooling dominant. Most of these city buildings are cooling dominant. So I think heating, so we're rejecting heat more than we're taking heat out of the ground. But one of the parameters that we would put on our control strategy would be that the geothermal loops do not go beyond freeze point.
Okay, very good. Matt asks,
Just to add to that, we did do a trial because when I back in 2004, when we were playing around with energy foundations, we did a trial at Lambeth College because people kept saying to me, the geotechnical engineering aspect kept asking, well, what happens if you freeze the ground? And I've been involved with numerous papers around the Lambeth College college in London, where we set a heat pump and we tried to freeze the pile over a 4-week period, whilst the pile itself was under working load condition. We had temperature sensors, vibrating wire strip sensors, fiber optic cables. It was a study done with Cambridge University, and there's some really interesting information about the effects of that. Interestingly, the head of the pile was monitored. So we went down to about -7 degrees Celsius for a period of 4 weeks, and what we saw was the pile itself settled by about 1 or 2 millimeters, so very, very small amount. But then when we changed to a heating mode, that 1 or 2 millimeters then recovered. So there is an effect on the foundations that we need to be mindful of, and as part of the standard that we're writing, we deal with that aspect. In the standard, so you do need to be mindful.
Okay, very good. Matt asks, how does the integration of geo loops in the piles affect the structural design?
Well, again, it's that conversation with the geotechnical consultant early on. One of the, as I said earlier, concrete is there to provide durability. And one of the slurry wall projects that we did on one of the Crossrail stations in central London, the cover from the excavated face to the reinforcement was increased by the diameter of the loop, because the loop was on the outer face of the reinforcement, just to make sure that they had adequate cover. So it's a design consideration for sure. But yeah, that hopefully that's answered that.
Coordinated with the designer of the piles.
Yeah.
Okay, very good. And Sylvie, points out some links on some research with a pilot that was installed in, I think, Waterloo, Ontario. So you can check the chat for those links.
Okay.
Then we have Arlene with 2 questions. Which geological conditions are ideal for energy piles, and which conditions would not be suitable?
Well, if your foundation's going to go down, like I said, 60 feet, I don't think there's any solution that isn't sort of lends itself to putting geothermal loops into buildings. I mean, in the city of London, we installed loops in lots of buildings. There's about 70 projects that I was involved with. It might be that we can't deliver. There's no way we're going to deliver all the heating and cooling to a large tower block. But one of the developers, it's all about. He wanted to make we've done as much as we possibly can. So we worked out how much heating and cooling we could deliver from the foundations that were supporting. I'm trying to remember the name of the building now. Next to the Gherkin. And we delivered all the heating and cooling to the atrium of the building. And I think if you go into the building, there was a monitor that sort of shows how much carbon is being saved from the geothermal system, the energy foundation system, on that particular project. The American Embassy in London was another interesting project that's got energy foundations. But I can't think of any ground condition that doesn't lend itself to this type of solution.
Even better. Okay, Arlene's second question, do you know of any examples where piles had to be extracted from the foundation for repair or other issues?
No, none at all. Again, it's about designing resilience into the system. It's about the QA QC during the construction process. Flow test, pressure test, each key stage. You know, we were involved in that project over with Google. They installed 3,500. They had about 5,000 foundation piles on that particular project. They only needed 3,500 of them. But as the project was progressing, you know, the QA QC process, you know, there was one or two where loops had been damaged, and so as you're progressing, you're recording the success rates and identifying any failures, and so you know, if you're controlling that, you know there's a problem pretty soon. So in that particular case, we were able to add in an additional loop in additional boreholes to cover any damage. And I think out of 3,500, there was probably 2 or 3 that were damaged. And it was, I've got a picture of a guy, and this is kind of education, you know, with everybody, you know, and the important on big projects, you know, nobody wants to be the reason for damage, and the human nature is to, oh, it wasn't me. So we would have toolbox talks with all the key guys and say, look, if you damage this loop, tell us, because it's a real pain in the backside if you damage it, and then at the end of it, you know, you've got 400 or 500 foot geo loop, the pressure has dropped off. We've then got to go and find out where that damage has occurred. It might be simple, but it might be just a drip. Let us know. There was one case, as I said, on the Google project, where there was a guy that was cutting reinforcements over the geothermal loop, so all the hot sparks were dropping onto the geothermal loop. You know, said to him, you know, this is plastic, what are you doing? You know, so it is about education. But our QA QC processes, you know, it's going to go into the building. You got to get it right first time. You know, designing the resilience in, like I said, the 561 Greenwich, each pile was headed to a manifold. The Google projects, we had 4 piles grouped together. Each one of those groups was run to a sub-manifold. So you can design in resilience. If you linked everything together as a daisy chain, you've got you've got a single point of failure. But if you have multiple runs to sub-manifolds, you increase your resilience.
Okay, very interesting. He asked the question, can a standalone geo system support active domestic hot water loads of a building, or do we have to rely on other auxiliary technologies for domestic hot water loads?
Well, that comes back to, I mean, most buildings are cooling dominant. And one of the things that we're always looking for is how do we balance the heating and cooling load? The cooling load is generally enormous. So we can provide heating for hot water. That helps us balance our system. You know, that would be, we will be looking to deliver heating to hot water as part of the geothermal solution here.
Okay, very good. And Richard comments, water to water units may be used for that purpose.
Yeah, absolutely.
Trevor has a question. Any input on concrete makeup for conductivity, or just use what structural demands require?
So generally, concrete will have a high silica content anyway. And it's, you know, one of the things that we did on several of the projects was to measure the conductivity of the concrete being supplied to site, just to check what we were doing. And I did, one of my slides, I forgot to show it, well, I mentioned it, was we did a conductivity test of an energy foundation to verify our design assumptions. The thing with an energy pile, the conductivity test is not a 24-hour process or 48-hour test. It needs to be run for a lot longer than that. You've got to see the sort of the curve really start to dip. So you can imagine on a very large diameter pile, you could be waiting for quite some time. There is some debate as to whether a single conductivity test drill down to the depth of the pile is going to give you the kind of conductivity value you need. So, but there's a lot of work done by Fleur Loveridge from Leeds University into conductivity testing of energy foundations, and Fleur's a part of my committee writing this energy pile standard with all those acronyms. I can't remember.
Sorry?
I said Fleur's part of the committee that has all those acronyms that I can't remember, the CSA, NSE.
Gotcha. Thank you. A lot of interest here. If you have time for a few more questions.
Sure.
Okay. Ruben asks, for the energy piles, did you find any limitations with conventional analytical tools, software for ground thermal conductivity, and thermal capacity modeling?
I think we've used GLD Gaia over the years. There is a function on it that allows you to coordinate the position of each loop. And that is an important element in that way you design energy foundation solutions. And again, it's that the long-term monitoring. I think is an important part of this 561 Greenwich project. We're going to get a lot of information about the performance of the foundations to help us improve our knowledge. I think there's a lot of research about using energy foundations short term. There isn't any sort of long-term knowledge, and what we've installed on at 561 Greenwich is going to help us inform and better design energy foundation solutions.
Okay, very exciting. Victor asks, I didn't hear you mention continuous insulation under building when you apply energy foundation to slow heat transfer from building to energy foundation. Are you applying continuous insulation? If so, which type of insulation have you found successful?
Well, on the 561 Greenwich projects, from the manifold to the main manifold, we insulated that with simple 1-inch Armaflex.
Okay.
But if it's running underneath the slab, and we probably wouldn't run any use insulation.
Very good. We have just a couple more questions, but we are half past the hour, so I'll send those questions to you if that's okay, Tony, and then we can get back with the individuals who asked the questions. I certainly appreciate your time, and thank you so much, everyone, for joining us. The recording will be posted in the next couple of days at IGSHPA.org. Just look for the YouTube icon at the very top. Thanks again, Tony. Appreciate it. Great presentation. Everybody have a great rest of the week. See ya.
Thank you all.